Okay, I have started the recording as well, and it will be available later on. So, just again, all all my details for people joining later, watching on any of the other channels, um, if it is by Unisa or on YouTube or wherever you will see this, just that you have my information and that you can join the WhatsApp group. Tonight's session, we will focus purely on 1630, and then the session tomorrow morning will be for 1520. As we get closer to the exams, I thought let's just rather give you enough time to that we focus on both of the two subjects. Okay, so just a recap, we in the last 2 weeks we basically focused on two things. So the first week we focused on simple interest rate and compound interest rate, where we looked at simple interest rates where you really could not use your financial calculator, or Excel in a sense with calculations. We also looked at simple discount. And then we also, about 2 weeks ago, also looked at compound interest. Compound interest is very much like what when we look at annuities, um, it's just a bit different phrase. So instead of annuities that we will put in monthly amounts, compound interest, when we looked at that, it was an amount that you will put away for a certain period, and you will then or needed to calculate the interest that you got on that, or you would have needed to calculate the future value of that. Um, so that was nearly the first week. Then last week we looked at annuities, and we used a lot of Excel for our calculations. We will again tonight focus a bit on Excel as well, but I will also give you some of the ways that we do it on a financial calculator. But last week we looked at annuities. We looked at the different ways how we could work it out. Um, we looked at annuities that are at the end of a month. We looked at annuities that is the beginning of a month. Um, if If you do it in Excel, this you will just change the function in Excel. If you do it on your, and I'm looking now at my HP, on my HP calculator, there's a begin and end function. So last week when we looked at ordinary annuities and annuity due, the big difference was then if we needed to change the function on the HP. Um, so if you have HP or Sharp, just remember, um, after you've done a calculation, to reset it. And sometimes, um, by resetting it, it means that you actually need to change it back to the original functionality. I'm just quickly checking for something. Um, Okay. Then what else did we last week? That was, I think we did all of we looked at payments per month. We looked at the perpetuities. So that was everything last week. So this week, we are going to look at chapter 5. So we're going to look at amortization and sinking fund. So just a quick nearly overview of that. And then I think we will have time also to look at evaluation of cash flow. So I'm hoping that we will be able to look at both tonight. So let's just see. I also want to show you how I would have done it in Excel as well. So again, I will have Excel open, and as we go through it, I'll just show you that. I assume that all your assignments was now needed to be completed already. So before we started, did you get any feedbacks on your assignments? Is there a way that you can share it with me, or was it basically everything online and they did not give you feedback on it? So, did they give you feedback on your assignments, and is it in a way possible to share it at all, or not really?
We did get feedback, but it's all online. But I'm
Okay,
not
so
sure if I can share it.
okay, and is the feedback more like the answer would have been A instead of C or something like that, or would they have at least given you feedback on how to calculate it?
They did. They gave us feedback on how to calculate it.
Okay, 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 but yeah, so it's probably so that you not have access to it probably when you write exams and stuff like that as well. I assume. Okay, but okay, cool. If anyone can share it, or if there's a way, please do. But I also understand if it wasn't in any shareable format, then it's very difficult. And I know they're starting to make it less easier for people just to share it across mediums. Okay. Okay, so let's get into chapter 5. So I think what is important here is, and again, how they will ask it can be twofold. So they can ask you in a sense where this was now an amortization table, and they can keep some of the cells open and nearly say, but you need to calculate it, or you need to basically say out of something or they give you the information and you need to basically get to the answer. So they can do it this way, or they can also, in a sense, ask you a certain number of questions around amortization. So the one that I thought, there's two that from the examples I nearly want to show you, but I also want to nearly show you then how to do it in Excel, so that you have a way of doing it in Excel again. And I don't think I have shared spreadsheet yet, so I will share that after tonight's session. Okay, so I'm gonna just copy that. If it now wants to copy, into Excel, and then I will just run through the question, and we can see how we can then build something in it for you. So you can see in example 5.1, so they talk about a loan of 10,000 with interest of 14% compounded quarterly, is to be amortized by equal quarterly payments over 5 years. The first payment is due at the end of the first quarter. Calculate the payment. So basically, amortization, you can think about it as you need to pay off your home loan, you need to pay off a car loan. So you buy that upfront. They work out a premium that you will pay back to the bank or to whoever you have loaned it from. And in a sense, we then know how the banks work is that the first period is normally you pay more interest than actually anything else. So the longer the loan up front, you pay actually a bit more interest than it comes to the end of the loan. So that is basically just in simple terms what amortization is. So in this example, they told us that we have a present value. So they told us that present value was 10,000 Rand. So I would just say minus 10,000. Let me just also make this bigger. Let's go by 200 and okay, so that was one of the things that present value 10,000. So what also you can do, so I'm using also the terms that is normally on a financial calculator. So it will be the same process. So present value, the future value, remember, is what it will be at the end of a term. So the future value will be equal to 0. So by the end of the term, there will not be any future value because you would have paid off the loan. And I think, again, the difference nearly between amortization, sure, big word, hope I pronounced it right, and versus the annuities is, with annuities, you will get a lump sum of money in the end. With amortization, you basically know what your loan is at the beginning, and hopefully by the end of a term, you will then don't have anything that you owe on that. Okay, they tell us the interest rate per year is 14%. They tell us it is compounded quarterly. So that means, I just want to check, compounded quarterly. So then remember your interest rate is actually the 14% divided by 4. So just remember that. I hope you just make it percentage, but it is already set up for you that way. And let's just make it okay. What else do they tell us? They tell us that equal quarterly payments over 5 years. So years is 5, but again, remember it is quarterly, and then there is actually then 20 terms in those 5 years. So just again, the calculator would automatically, if you say it is 4 times a year, it will automatically create that. But just if you use Excel, you need to tell Excel. Excel is not, in that instance, as clever as the financial calculator. Okay, so if you then, I just quickly want to check this out. Okay, so the only thing that is left then is that we need to calculate the PMT. So there needs to be a PMT function. So let's just do that, PMT function. The rate is for 3.5, so we have already changed the rate into what it will be. Okay, so this is interesting. Let's just, basically did that. So the total number of payments, so total number of payments is the 20, so it again already takes into account, and then the present value is that, future value is 0, and then type is where we had it the same with the annuities. If it is the beginning of a period or end of a period. So if you don't specify, it is like we normally work out with our calculator. It sees it as how it's traditionally done. And then your PMT will be 703 Rand and 661 cent, as in the example on, I hope we've got the same nearly study guide, example 5.1 on page 81, 82. So we could have used all of that information as given into your financial calculator, but also just a way to use it in Excel. Before we go, does this help you? I'm just worried that I'm doing something that will this help you in the exam? Will you be able to, or not be able to? Are you more likely to use your financial calculator, or will you also maybe use the Excel in instances for the exam as well? Just nearly want to get a feel. Or are you basically looking at all the different options and you will decide closer to the time of the exam?
I think I will decide closer to the exam.
Okay. Okay, no, that's also fine. And I think that is, in a sense, what's also nice about the open book. You can decide. So all the options are there, and I'll just nearly try to explain a lot of the options. But in the exam, the one that that's the easiest for you, you can use as well. Okay, so that was looking at example 5.1. Let's look at one of the exercises as well. And again, I'm gonna copy that out. So I'm actually gonna copy both of them out, and use it in the same sheet. And let's just see if we set it up, we put it in that we can show you both in the same exercise. So I will just nearly build it next to one another. So they tell us in the one, draw up an amortization schedule for a loan. Wait, I am definitely not reading the right one here. Oh, okay. I'm already at the at the next one. So that is exercise 5.1. I was already at exercise 5.2. Okay, so you purchase a small apartment for 180,000 with a down payment of 45,000. You'll secure a mortgage bond with a bank for the balance at 18% per annum, compounded monthly with a term of 20 years. What are the monthly payments? So that's basically, if anyone has a home loan, that's nearly how our home loan is structured. So let's just make it a bit bigger, again for you to see, and then also some of the interesting things that one sees in that. Okay, so I'm just going to say this is question 1. If question 2 has the same things, we'll look at that. So you purchase a small apartment for 180,000. So that was the original price, is for 180,000, but they tell you that you made a deposit. So in actual fact, the present value is less. So it's 180,000 of what it should have been. You made a 45,000 deposit, so your present value is actually 135,000 rand. At the end of the term, your home will be paid off, so your future value will be 0. They tell us what else, that your interest rate is 18%. But remember that interest rate is calculated monthly. So your interest rate is when in actual fact the 18 divided by 12, because it is monthly. We just again need to make it percentage. I'm just going to say next to it monthly, so that we know. Then the term is so the number of years is 20, but because it is again for 20 years in months, we need to multiply it by 12. So 20 times 12 gives you the monthly terms. And then the last thing again we will work out is what is your payments per month. So BMT again, the interest rate was with 2%, with time period 240, future value, present value is minus 135000. No, the future value is going to be 0. So your payment for that on a monthly payment would have been 0.8347, and that's also what I get when I also put that exact same numbers into a financial calculator. So again, I think the important things here was that we just, for Excel, need to remember that we use the interest rate for monthly terms, and the same if you look at your period, that you look at the monthly period and not in full years. Okay, so that is then your answer to question 1. Let's see if we can, for question 2, just use some of the same principles. So question 2, they talk about your great aunt dies and leaves you an inheritance of 60,000 rand, which is to be paid to you in 10 equal payments at the end of each year for the next 10 years. If the money is invested at 12% per annum, how much do you receive each year? Okay, so it's an upfront payment or an amount that pays out yearly. So the last payment will be 0. Your interest rate, so let's put it in here, as that will be the one that was put in the calculation. So your interest rate is 12%, and then it was for 10 years. So basically, if you inherited that money, you would get an amount of 10,619 rand every year for 10 years. That's actually, I'm now thinking about it, something that they can then ask you is, with the inheritance one, is how many, and I just now need to get, so what they could have asked you, and that is what we will get to in the next one. So they could have asked you nearly what was the interest paid. So if we know that this amount was paid for 240 periods, so you borrowed, and that's why they say why a loan is so expensive. So you borrowed the money, it was 135,000. You paid monthly the 2083. So that was the amount that you paid in extra interest. So what I did was just to say, well, the periods per month, or the payment per month times the number of times that I paid it, minus my initial, that is what the interest paid was. Now the same is if we look at the other side. If you look at this money that you actually had inherited, so you look at that, instead of taking that 60,000 up front, if it was paid over 10 years for you at 10,000 every year, you actually receive 46,000 more than you would have if you took it all as one payment. So again, the positive, if you get inheritance money that is paid out yearly. The negative, if you pay a loan, you obviously are paying more than what the interest was. So I just thought, let's add that. I don't know if they might ask it, but just something added into this. Okay, let me, while you guys are also here, just want to post an attendance register. You can at any time just complete the attendance register, then at least that is also done. Okay, so this is nearly was looking at, yes, yes, yes. So we will yeah, spot on. So that is the cost of a loan. Yeah. Okay, so let's look at one of these exercises, and let's see, how do we start with one of these? I nearly want to also do it, to show you in Excel how to do it. What is this exercise 5.2? Okay, let's let me take this and put it in Excel for you, so that you have it. We will make the calculations and everything. I'll build it now into it. Then again, you can decide which one you want to use. Okay, so the to see if there's anything else that I could have copied out, else I'll just read from the exercise. So they tell us in I'm just going to call it a more table. So they tell us in exercise 5.2, draw up a amortization schedule for loan of 4,000 Rand for 3 years at 12% per annum, compounded half yearly and repayable in 6 half yearly payments. So basically, what you have is 3 years times 2, so you will have 6 half years that you need to look at. You start off with 4,000. Let's make that an amount. So your interest paid is a very simple calculation. So your interest paid in that is your original 4,000 Rand. Your interest rate. Okay, so let's see if I can just do that. I will, so that when you do it, you can just change some of the numbers. So that the information is already built into it. So let's see, 12%. Was there anything else we will see now? That is 4,000 times your interest. Okay. So you will see that was not the 240. And so what we add is payments per year, which is twice a year. So all that we do is then just say divide by that. Okay, so that would have been your first period interest that we have calculated. The payment that you're making is we can again use our PMT function for that. So let's see, the rate was divided by 2 because it was twice a year. That we need to times, or I would just say times that by that 2, so that we can change whenever we need to. Your present value, I'm going to add that into that block, which would be the 4,000. So let's just do that. Okay, so there you can see that was the amount that we calculated. And that is now your payment for every period for the 6 months. So I would just make it that it is equal to the previous one. And in here, I would just say, and I can at least look at what the total is, so that again, if one needs to say what is the cost of the loan, you have that into this as well. Okay, so we've calculated the interest, we've calculated the payment. So the principal repaid is basically the difference between those two. So the principal repaid is the payment minus the interest, and then your principal at the end of a period is basically what was at the beginning minus your principal repaid. Okay, so now what we can do is that will now be your new principal or outstanding amount. We can say that so the one thing that I just need to add to that formula is we just keep it, but it doesn't move. Let's quickly check. Okay, it is nearly there. It is B2, so B2, I just want to check where B2 is. So it should be I2, I3. Okay, cool. So now that is also ready for you to use. So basically now you can see the next one, the interest is less because your outstanding amount was less. Your monthly, your quarterly, in this instance, your half yearly payment stays the same. So the principal repaid becomes a bit more. Okay, so because your interest is becoming less, your principal repaid is becoming more. And then you can see that when at the end of that period, your principal becomes less as well. Then let's see if it automatically does that. So now we can actually, supposedly it should have helped. Okay, because I haven't changed that yet. And also because I haven't changed that yet. Okay, so let's just check which ones must we complete and which ones do they see as numbers and not. Okay, so that is correct. So I have not done that. Okay, so I've just now copied and dragged everything into its positions. So you can see in this table now, the first one we calculated, then I just used the formulas. So that would be your new value. Worked out the interest, payment stays the same. Your principal repaid becomes a bit more because of subtracting the two. You get your new value. Your new value at the end of that term becomes your present value, and you basically continue with that process. What you will then in the end see is that your principal at the end must be zero, so that will be your future value will be zero. Your interest, or you can look at from two ways, is to say your original plus your interest would be then the same as your total payments. So that can nearly be a check for you to say, well, let's look at what my original plus all my interest rate was, and if it is the same, then at least I know what I've done and what I've calculated during the process is the same. So what you now can, if it's a different value, let's say it was 6,000, it will automatically change. I just think this one we then need to say 6,000 as well. So you will see there it becomes similar. So just to make 100% sure that we do this right. So whenever you now change that, it will automatically change. So that is input is linked to that one. Okay, so again, something that might be useful for you to use in the exam. You can add rows to it, you can take away from it, you can change it as you like. So I think it's just a nice way of simplifying it. So if you need to add in here, insert, you can drag those numbers down. If you need to then recalculate an amount, you can do that as well. Okay, so that is one way of looking at the amortization schedule. Let's quickly just check in and see if you're happy with that. It's quite a lot at one time. So yeah, let's just have a quick check in and see if you're okay up until now.
I'm okay.
Okay, cool. Okay, so let's then look at the next one. So let's look at an example again. So example 5.5, where we're also looking at some of the information. Let's look at what we need to do, and then we can get into sinking funds. So I'm just want to copy that out so that I have some of the information at hand. So they tell us in example 5.5, suppose that the interest rate on Jonathan's loan of 480,000 will remain fixed at 13.5% for a full term of a loan. What is the total real cost of a loan if the expected average rate of inflation over the term of the loan is 5.5% per year? Okay. So that's an interesting one to work out. So let's quickly see if we have all the information. So we have present value. So if we work out, and let's just make this getting bigger. Don't know why it does not automatically stay in that format. Okay, so we've got our present value that they tell us. So they tell us that Jonathan's loan originally is 448 or 480,000. So we have that. So let's just work out first what the total loan will be. So we have it as 20 years. They told us it is 12 times per year. So it is, again, if we're looking at it from a home loan perspective, they told us the interest rate was 13.5%. And what else do we have? I think that is it. So we first want to work out what that monthly payment is. So to check, is that it? I haven't missed anything. So the rate again, it is 13.5% divided by the 12 because it is compounded monthly. The period is just the opposite. It's 20 times how many periods there are. Future value was that. Sorry, the present value. Future value is 0. They tell us, do I say end of the beginning? No, so we assume it is as normally the end. Okay, so basically what we have now first worked out is to say our monthly premiums is, or monthly payments is 5795. So then what we will then basically do is to say, well, if we have that amount, we now need to include interest into it. They told us that, not interest, inflation. So they told us that the inflation rate is 5.5% per year. So what we now need to do is to say, okay, so I actually now need to work out what is the future value. Sorry, the present value. So I need to now nearly work out what that is. So let's start with a new one. What I have, I've got my PMT. So I am just going to copy that or use that. So what else would I need? I still have the 12 over 20 years. I've got the 12. So I need to include the inflation number, which was 5.5%. And the rest is supposed to be the same. So let's quickly check if that will work. Present value. So the rate was your inflation rate divided by 12. Your period was 20 times 12. Your payment was that. Okay, doesn't make it negative, so let's just make it negative in front. Future value is 0. So your present value of that would be 842,492. And then, as we did with the previous one, to work out what your cost is to servicing the debt, is basically to say, well, remember we had that as negative just for the calculation. So then I can just say it's 1 is that one plus that one is the amount to service the debt. Okay, so again, like in the previous one where we here showed your, and let's just call it the same thing, servicing the debt. Okay. So basically what we did there and what we did here was exactly the same. So again, if we did it on a financial calculator, we would have just gone the same way to say present value times per year would have been 12. Your interest rate would have been 13.5. Your period will be 20 years. So your monthly payment on that home loan would have been 5795. But then you want to also find out if there's an inflation rate linked to it. What is your cost? If we did not have that inflation rate, we basically would just have said that amount times the 240 terms that you would have paid it. So then it would have been exactly like we did in this instance. We would have just multiplied it by 250, but they told us there is an inflation rate that we need to work with. So that is why we needed to first work out a new present value because of that inflation rate. If there wasn't an inflation rate, it would have basically been that times 240, and that would have been your present value that you then would have subtracted your original amount from. Okay, so that is if you look at that was not exercise 5.4. I've now example 5.5. I get this is wrong when okay, example 5.5. So that basically is a look at amortization, the table, and then if you need to work out servicing of debt as well. Okay, up until this point, everyone okay with that? Then we can go into sinking funds as well, and then we can start looking at cash flows after that. Okay, so again, as you practice and you see other examples of amortization, also, even if it is maybe on one of your previous assignments and it's online and you can take a pic of it and send it to me as well, you can do that. That one can get access to other examples of it. I think I do have some of the previous papers. So after next week's session, I think we will go through a few of the exam papers as well. Okay, so let's go into sinking funds again. We have a definition. It's in your book. You don't need to worry about that. Um, if I ask anything about definitions, it is open book. So so that at least one can work with. So sinking funds, what you need to do in sinking funds is again very similar things that we've done in amortization. Again, you would work out in this instance two portions. So you will work out a portion, and in this instance, just quickly, we will go into the detail as well, but the portion is to do with the payments that you made, how many payments and everything that's linked to that, versus the other portion that will be linked to the interest that was paid or needs to be paid, depending on how the question is phrased. And then you will, like in the instance as how we looked at servicing cost, you would then nearly say, but what is the total cost when we look at the sinking fund? So again, let's look at example, and we can look at example 5.6. Again, I, as always, will bring it into Excel that we can work around that. And then we can again see why some of my, okay, cool. Okay, so in example 5.6, again, we talk about a debt of 10,000 Rand, bearing interest at 14% per annum. This needs to be paid half yearly, and it must be discharged by the sinking fund method. If a sinking fund earns interest at a rate of 12% per annum, compounded quarterly, and the debt is to be discharged after 5 years, determine the size of the quarterly deposits. Okay, so firstly, the quarterly deposits will be your PMT that you will calculate, and then what is the yearly cost of the debt. So that will be your total that you need to calculate. So we will need to work out a PMT. So for a PMT, the things that will be needed in that formula is future value, present value. We will look at the interest per year. If there is a period per year that is involved, let's just add that as well. Interest rate, and then N, which is your term. So they told us a debt of 10,000 Rand bearing interest. So your future value is for 10,000. You will not have a present value. Your interest rate is a debt of 10 bearing interest rate of 14% to be paid half yearly. If a sinking fund earns interest at the rate of 12%, okay, so your interest rate is 12% because that is what a sinking fund earns. They tell us compounded quarterly. Quarterly is 4 times a year. So let's just get that right. And then for 5 years or after 5 years. Okay, so your BMT, so it's after one has set nearly up what needs to go into it, it is much easier. So your periods would be with times 4. Your present value is 0. Future value is that. So your PMT is 372 Rand and 16 cent. So then what we also need to work out is that interest component. That interest is basically, if you look at the formula, it is your simple interest. So you basically say what is your beginning value, what was your interest. I'm gonna add in here a value so that it's already calculated, and they tell us that is, I think there was half yearly, to be paid half yearly. So let's just say times 0.5. I'm gonna add something in for that as well. So and then period, you can do that rather. So that depending on what your period is going to be, you can rather have it in there. Okay. Okay, so then basically how to work out your yearly cost is a sum of two things. So it is, if you look at your interest, it is twice the interest because there's 2 periods. So it's a half year plus a half year. So that is why it is times 2. It would have been nice if I could have done, I will think about how to make that better. Just so that it makes a bit more sense. The other thing, I think what is important here is that we're talking yearly cost. So because it's yearly cost, we can't use all of the rest of these numbers as just to multiply out again. So very important yearly cost. So it is the, let's just make sure it, okay, so it does that. So that was the interest component. And then the other component is, okay, so luckily we can use that because that is how many times per year. Okay, I now know what I'm going to do with that one. And it was the payments. So what we can do with this one, I'm going to think about something there. But the yearly cost then is basically the payments for 4 periods and the interest for 2 periods. So it would have been that times 4 and this times 2. That will be your yearly cost. So again, depending on what they ask around the sinking fund, they can ask you what is your quarterly deposits that you need to make. They can ask you what is your yearly cost. They probably could have also asked you what was the total cost of the 5 years as well. So again, just depending on how the question is phrased, they can ask it in a few different ways. Okay, seems like we've lost a few people. Caroline, it seems like it's just the two of us now, as I think load shedding has hit some people to drop off. But we can continue. Okay, so for now, we have basically looked at the sinking fund part as well. What for me is important nearly is that there's, in each of the ways, there's nearly from simple interest through to sinking funds. Everything has a way of it being done. So at the moment, it's nearly, you look at the calculations with your calculator or with Excel. It's the same functions. So, but you must just, in a sense, tweak it a bit to work out a different value. So the only thing that's different between the sinking fund is that they nearly ask you to work out a yearly cost. So you still work out a payment per month or payment per term or payment per period. You work out the interest that you would have paid on a yearly basis or half yearly basis or quarterly basis. So the important thing nearly for me in the sinking fund is that you what the easiest is to get wrong is that you use the wrong interest rate for the wrong calculation, or that you use the wrong period for the wrong calculation. And that's nearly the only thing where I can see where one can nearly make a mistake with a sinking fund is that you, instead of what we had in this, that instead of the 12, you would have used for 14%. And instead of quarterly one, you might have used half yearly. So that for me is nearly the important thing is when one look at the sinking funds, it is to identify what the numbers are that you need to work with. Okay, so that is sinking funds with amortization. So let's go into cash flow. So Caroline, since it's only you, is this fine of what we've done on amortization and sinking funds? Is
Yes,
there anything?
that is fine.
Okay, so where are you? What's for you the most difficult part of this study unit, or from 1630 at the moment?
It's like the data thingy.
Okay. Okay,
like
so
I can't get that one.
okay, no, so that's fine. We will actually, okay. So I will make sure that we look at the data one actually the next week. The whole chapter 8, is that one of the things that you?
Yes.
Okay. Um, and for that, Excel is wonderful to put it that way. So do you have nearly access to Excel when you're writing exam or not?
Yes, I do.
Okay, so that would be perfect. So I will make sure that for the handling of data, we'll set up the spreadsheet nicely for that. Even if it is a separate spreadsheet, we can do that as well.
Okay.
Yeah, because that's the stuff I like is is chapter 8. So we'll make sure that there's no problem for you on that front. So yeah, so I will make sure that next week we can work on chapter 8, and build some real nice things into Excel for you as well.
Okay.
If you have examples of that data questions, from assignments or something like that, you can send it to me on a WhatsApp. So even if it is a picture that you take or something like that, then I can actually prepare the Excel nicely for certain instances as well.
Okay.
Cool. Okay, so let's continue then, even if it's just the two of us on the next chapter, and and at least some of the guys can watch it later on. So when we look at chapter 6, it nearly is around evaluation of cash flows, but what it will ask you is different ways that you can evaluate if the money that you're putting into a project will be making it profitable or not. And they can ask you in a question if by using the one method versus the other method is better, and if it's making you profit or not. So again, depending on what they want to look at, they can structure it a bit differently. So the only thing nearly for me is that there is some formulas that one needs to know. I think and again, if I look at, when I last look at it, there is, so the internal rate of return is there, MER is there, so that at least is part of your set in Excel. Your net present value should also be there. So at least those are part of the set of internal formulas built into Excel. I don't think the average rate was. Yes, the average rate wasn't. So that is just again one that one will need to work out by using the information available. So normally it's interesting. They say, and I took that note out of one of the study guides. The big focus on internal rate of return and net present value, and then I know in that first year I looked at 1630 when we asked the question on our average rate of return, and everybody was nearly, but where was that in the study guide? And it's right at the beginning, and nearly everybody looked past that. So and even if you look at my focus areas was not on that average rate of return. So just if you have to look at average rate of return, example 6.2 is a very straightforward one of average rate of return. So you basically in example 6.2, you get a table, you work out what the total is. So you work out what your average after tax income will be, and you divide that by the total investment. So in example 6.2, you had two data sets or two sets of information, where the one was an investment of 20,000, the other one was an investment of 16,000, and they told you what the interest rate was, so that you just needed to then decide which one would be the best. So if you're struggling with the average rate of return, example, and let's just nearly add it in here, example 6.2 will be a good one to look at. Okay, let's add it just as an extra. So let's build it quickly for you in in Excel, so if we needed to work out the average rate of return, we had a table, so it was proposal, and I'm just going to say proposal A, proposal B. It was for both was for 8 years. They told us that the investment on proposal A was 20,000. The investment on proposal B was 16,000. Seems like that was a consistent 2,000 a year. And B was a bit different, so there was a few payments of 1,000, then there was 3 payments of 1,000, or 2 payments of 1,500, 1 payment of 2,500, and a last payment of 3,500. So we could have worked out the totals. Okay, so the one was basically looking at a total of 16,000, and then the proposal B was looking at a total of 14,000, and then the question was, okay, so you're considering these two proposals, which one would you choose on the base of the average rate of return? So if I look at the average rate of return for, and let's just average rate of return is 16 divided by 8, because you had a total of 16,000. Average rate of return for the first one would be 16 divided by 8, and for the second proposal it would have been 14 divided by 8. So your average rate is, for the first one is 2,000, for the other one 17 or 1,750. Sorry, so that is not your average rate of return, that's just your average rate, that we don't make a mistake there. And when your average rate of return is just looking at that 2,000 divided by your initial, and we put it in a percentage. The same for the second one. It would have been your average rate, which is the 1750 divided by the 1600, which give you 11%. So again, let's just make it rounded off to 2 decimals, but we can just look at it. So interesting, one would have maybe thought that first the proposal A seems better, but actually proposal B has a better average rate of return. Not a lot better, but it has, instead of 10%, you're getting nearly 1% more per year. So 11% versus 10%. So on average rate of return, you would have gone for proposal B. Okay, so yes, we said in the there's not a lot of focus on it, but if you need to look at it or need to use it in the exam, you have an option, and that is to use this table now in Excel. Okay, so then the other two things that we will look at is internal rate of return. So again, you can look at the definition of what they tell you. There is some formulas on in the study guide as well in chapter 6 for both the internal rate of return and the net present value. I would rather use Excel, so let's use Excel for that example. So internal rate of return. Let's just again make it bigger. So I haven't worked in a while with internal rate of return, so let's see what is needed. Okay, so here they wanted, so your values is an array of reference to cells that contain numbers for which you want to calculate the internal rate of return. Okay, so you need a bit more information. So let's see if there is anything else. Okay, so let's do it the old-fashioned way. I'm gonna test it as well with example 6.3, but let's first do it by using the information that they give us. So Trevor invests 10,000 Rand, so we know that 10,000 that he invests is present value to yield a single cash flow of 18,000. To yield a single cash flow of 18,000 at the end of 4 years. Okay, so in this instance, this would have been a very, I want to say, straightforward. We would have wanted to work out what your interest rate is. This is, now I'm actually wondering if Excel will do this for me. I don't think so. Okay, so we will need to work it out firstly with the financial calculator. I now need to look for what the formula is that we're going to use for the internal rate of return. Okay, so on your financial calculator, we would have said minus 10,000 present value. We would have said 18,000 future value. It would have been, just want to make sure it's once a year. So that we just get that. It was for 4 years, and then you will work out your interest rate, which will be 15.83. Okay, so round it off. Let's see. I think this will work. But Why not? What is we guess? Is a number that you guess is. Okay, no, so see, so yeah, okay, I'll get another. That's not gonna even give me anything close to what I need to get. So I am gonna look at another way to do it in Excel for you guys. Um, how we do it in a financial calculator is just as we always would have if we had to work out if you were given a present value and a future value and you needed to work out your interest rate, it would have been the same that you will basically for an instance like this work with your future value, your present value, and the period of time. I will not be defeated by Excel, so might even be that we look at exercise 6.3, and if one put in those numbers, um, last one to try, else we will use the calculator again. So if we add the numbers of 320,000, 80, 110, 120, 90, and 70,000. Okay, so let's just quickly check. It is 320, 80, 110, 120, 90, and 70. So if it can be internal rate of return, okay, so there we have it. So if we just have a set of values, then we can work out the internal rate of return. Okay, so we have the normal future value, the present value, and those kind of things. We use our financial calculator, but if you have a set of numbers, you can actually use then the Excel formula to work that out. So that is actually quite cool. So we'll just make sure that it is not by pure luck. So let's just check the second or the other example 6.5 as well. So minus 120,000, 60,000. So already by having two numbers in, it starts calculating it. And there we have it. So yeah, so for internal rate of return, as simple as this. You just put in your numbers and it will work it out for you. Okay, so there is definitely also a formula in the study guide in chapter 6 that you can use. But if you find with Excel, use what is in Excel. Okay, then the last one for tonight is, I think, net present value. So we've done internal rate, net present, and there is obviously the mirror one that hopefully we can also do in Excel. So the net present value. So again, same principle like in the previous chapters. We basically need to work out what is all the present value or the future value. They will need to tell you which one. They need to give you at least most of the information. So if they don't need to give you the present value, you need to work it out. Like in example 6.6, they give you, they say a shopping complex may be purchased for R1 million. So you know that you can invest R1 million. So now you need to see, well, if what the profit will be, or what the investment will be, or what you will get out of it in the end will be profitable for you or not, if you will go forward with the investment. So again, what will probably happen in Excel is that we will need to, in Excel, will be about a set of numbers. So like in the internal rate of return, I assume the same will nearly happen in Excel for the net present value. Is that for net present value, the assumption would be also that you need to put in an array of data. Okay, so they actually give you rate is the rate of discount. Then they tell you, okay, the present value of investment. Okay, so you can in here add as many numbers as you want. So let's quickly check for where that information was that I took this from. Was it exercise 6.5? I just want to check. Yes, exercise 6.5. So exercise 6.5, it tells us an investor contemplates two investment proposals, A and B. The investment and cash inflows are tabled below, which is this table here. And then it says, do it that way. Let's just put it as values that if we need to use it, we can. Okay, then it says compare the use of a net present value and per profitable index by choosing between two alternatives is the cost of capital is 12% per annum. Okay, so we know that the cost of capital will then be your interest or your rate. So your rate is your cost of capital. What they said was 12%. Let's see if this will work. Okay, so it ended, and let's just do the same for the second one. And then we just need to say what was. Okay, and I think that is what was the two was 27,710 and 32,105. Okay, so we definitely can use this to work out a net present value. So if it was purely on money, obviously proposal B will be the winner. But if you look at the profitability index, then it will be, let's just see how the profitability index is worked out. So it's the beginning plus the extra divided by beginning. So the beginning plus the extra. Oh, so it's that divided by. Okay, so the one was 1.28 and the other one was 1.27. So obviously just close enough for 1.28 on profitability index is a bit higher. Okay, so again, it is possible if you have a set of data to work out your net present value. And I think it will be the same with MER. And again, let's see. So this one was a calculation. So if we get, what is it, 20.81? No, it is correct. So let's see what the MER function asks us. It actually asks us all the other stuff as well. So let's quickly see. That was example 6.7. So assuming that we can borrow funds at 18% per annum, whereas an investment with comparable risk can be expected to invest at 15% per annum. Okay, so that was the 18%, 15%. It will probably give me that. So let's just make sure that we're sitting with numbers. Okay, and the MER was 20.81. So let's see if okay, perfect. So again, in here, so let's just add two things. So borrow at interest was 18%, and then what you can invest it for is 15%. So at the next time, if you guys need to do it, you can just change this. Cool. So there's also a function for merge. So again, nearly these last four will hopefully save you a lot of time when you get data tables to work out the cash flow. So that's why I wanted to show it and to show you in Excel how to do it. Okay. Caroline, since it's only you, hopefully this will also, the Excel part will help you, as I think it might just give you a bit more extra time for some of the other problems if you can only put in values into this.
Yeah, I think it will be very beneficial for me.
Cool.
Because
Okay,
I'm also I'm struggling with a calculator.
Yeah, and I think it is the calculator for certain things it's fine, but as long as, so when we start talking compound and monthly, and then you need to change things, and then normally what happens is the one question is monthly, the next question is quarterly, and one forget to switch it back or things like that, and that normally catches you out. It's normally
Yeah.
not the question itself, it is those things, and they purposefully do it in any case, so it's they know.
Yeah.
Yeah. Okay.
Okay, you didn't
Okay.
put the attendance register up, did you?
Let's I hope it is this one. Let's quickly see for myself as well if it is. Yes, it is now in that link.
Okay.
Cool. Thank you very much. I'm going to stop the recording as well. But I will definitely make sure that